Good morning, everybody. My name is Enzo Pezone, and we are here at World Hydrogen Week 2025. And I'm pleased to be joined by Jeffrey Benoit, Vice President Clean Energy Solutions at PSM. Good morning, Jeffrey.
Good morning. It's really great to be here. Thanks for having me.
That's great. Firstly, I would like to start with an introduction of you as Vice President of PSM and what PSM is doing in the clean energy space and how it relates with the hydrogen industry.
Sure, that's great. So PSM, we're actually a Hanwha company. We're owned by South Korean-based Hanwha Corporation. We've been owned by them for about 4.5 years. Our focus is very simple. The installed fleet of gas turbines require them to be upgraded, modified, converted to allow them to effectively participate in the clean energy transition. There's abundance of renewable energy that's coming online globally. I am primarily focused in the United States, but with extension into Europe as well as the Middle East. And we provide our own technology in the major capital components and the refurbishment of these capital components that can be installed into a customer's gas turbine, which can be used for power, either peaking power, combined cycle power, cogeneration, industrial applications. But it gives them a different type of value proposition, whether they need the gas turbine to operate much more flexibly in terms of operation, improved maintenance and life cycle cost. And the area where I'm quite interested is the ability for it to be fuel flexible. And our focus on developing combustion technology for gas turbines that will allow them to participate with hydrogen or ammonia in the clean energy transition.
That's great, and I would say this is very topical these days when you talk about power, and with most of the major economies coming up with more and more renewables, the flexibility of traditional power generation systems is going to be key, as well as the decarbonization. And you've touched upon fuel flexibility, combustion system that enable the combustion of hydrogen and ammonia. Could you tell us a little bit more in details? How you see the role of these clean gases in the industry you're involved into?
Sure. We see it as a step-by-step process. The gas turbine is incredibly flexible. It's a wonderful energy conversion machine with many thousands, tens of thousands of gigawatts installed. With the introduction of clean or decarbonized fuel, and the technology to do it, we see it shifting. These technologies, these combustion retrofits that we're talking about, have the ability to not only operate on 100% natural gas, but any variable range of hydrogen up to, in certain frame sizes, machines, up to 100%, while meeting emissions requirements and as a retrofit, without necessarily impacting any of the downstream hardware. In many cases, these are in combined cycle application. We have these technologies operating in many gas turbines. Most of them are operating with this combustion technology, which we call flame sheet combustor, to improve their operational flexibility and lower their emissions from an oxide of nitrogen standpoint. However, we have a number of them, not only in Europe, but in the United States, that are using refinery off-gas. It's available. There's a requirement not to do routine flaring. They need to do something with it. If you can put it into the gas turbine with the right combustion technology, not only can you use that and defray the cost of natural gas, you can lower the carbon intensity of the gas turbine itself. That's step one. Step two is to develop and really position the gas turbine as a very flexible energy conversion device. And we're doing that around the world, finding where hydrogen can support gas turbines in smaller peaking applications, simply because the volumes of clean hydrogen are not necessarily available yet. But introduce it into the conversation of clean power across the globe.
That's great, and thanks for sharing your insights there. I would say you mentioned that you have the fuel flexibility going with 100% natural gas and potentially switching 100% to these alternative fuels. Can you quickly spend a couple of words on the efficiency when you do all these type of changes in fuel combustion? Really interested to understand a bit more about that.
Sure. No, that's a great question, and it's one that we get quite a bit. So the combustion efficiency stays the same. The opportunity with hydrogen is twofold. You won't necessarily lose, I would call it performance neutral. However, if one is to match the energy content between natural gas and hydrogen at 100%, you have the opportunity to improve the efficiency because you're releasing more energy at 100% hydrogen into the energy into the gas turbine that can then be converted to power. And that's what we're seeing. However, the other option is to simply lower the flame temperature or the turbine inlet temperature slightly, and that would match the performance, but would also reduce the emissions of nitrous oxides. The balance is on oxides of nitrogen. There is a misinformation out there that when you burn hydrogen at 100% in a gas turbine, you will create huge amounts of oxides of nitrogen. However, the advanced methods in the way that we're doing it in what's called a dry, lean premix mode, allows us to meet the current NOx emission standards, so no selective catalytic reduction is required. The existing SCR that might be there can be continued to be used, and then it just becomes a simple retrofit with an introduction of a fuel blending skid. And we've done this a number of times already. We're simply looking for the right application with the amount of hydrogen, and we're also looking for the bounds of a measure of carbon, a pricing of carbon into the business and value proposition.
That's great. And yeah, of course, when you talk about hydrogen and the wide range of combustion that you can achieve with air, you can afford to go lean and then to reduce the nitrous oxide emissions,
Yes.
which is great. So thanks. The last one I would like to cover with you. You mentioned to me that you've also been involved in the decarbonization of the maritime sector, and with the recent IMO announcement of pushing with regulation and putting a carbon
Yes.
price. Could you tell us a bit more? What are your solutions to enable the decarbonization of the maritime industry?
Sure. We've been developing combustion retrofits for almost a quarter century. First wave was on reducing oxides of nitrogen with our technology. The second wave and current wave is with hydrogen. And now we're seeing with the maritime industry an opportunity to use a fuel, ammonia, not only as the energy carrier, but as the fuel for propulsion. PSM, being an independent service provider, compete against the OEMs for our customers. What we have here is a relationship, a very strong relationship, technological collaboration with Baker Hughes. And Hanwha itself manufactures very large shipping vessels, such as LNG tankers. And what we've done together as this collaboration is Baker Hughes will bring their gas turbine technology, small gas turbine technology. We will bring an ammonia combustion system that will be married to the Baker Hughes gas turbine. And we will deliver that to my parent, Hanwha, as part of an overall e-propulsion system. What's really fascinating here is twofold. One, not only is this a combustor that can burn 100% natural gas to 100% ammonia, with meeting the very stringent Tier 3 IMO NOx standards without a selective catalytic reduction or any exhaust treatment. But more importantly, this is a high efficient system. And what we're finding is that we will be delivering and are testing this combustion system today in Germany on a very fast pace for introduction into a Hanwha machine around 2028. The benefit here is with the upcoming vote by the IMO and the Marine Environmental Protection Committee on the amendments, should be next Friday. the 17th of October, we will see the need for ammonia as a core fuel with a global bunkering strategy, with ships that can be either developed with this new propulsion inside or as a retrofit basis. So we're quite excited about this. It's something that we're focused on right now with a lot of leadership's attention, and the testing and the development is going as we expected. Very excited to see it come to fruition to support the clean energy transition.
That's great, and yeah, really interesting to learn from you that you have real partnerships going on and real projects like the Baker Hughes and the German one. To say from us is all today. Thank you very much, and yeah, really nice to have you here.